All right, these are the answers to page 452. 3 and 6 just want us to set up an integral that would represent the area of in between these functions. So if we look at number 3, we can see that the g function is the top function in this, the f function is the bottom. So when I go to set this up, I'm going to set this up as g minus f, and then dx. And then I need to know where it starts and where it stops. So as far as x goes, it starts at x equals 0, and it stops at x equals 3. So just by looking at this picture here, that would be the integral that would represent that area. For number 6, a little different. We see that we have the f function that goes like that, and then we have the g function that's a line. So from 0 to 1, the f function is top, g function is bottom. So for number 6, I'm going to go from 0 to 1, f minus g dx. That'll give me this first part. And then from 1 to 2, we're going to flip it around. So we're going to add to this. I'll do it like this. Plus, from 1 to 2, we'll do g minus f. G is now the top function, f is the bottom. So that from 1 to 2, that'll be this area. Put those two together, and that'll be our total area. For number 17, we were asked to sketch a region of this and then find it algebraically. So I'm looking at this. I've got y equal 1/2 x cubed plus 2, y equal x plus 1. So what I'm going to do is I'm going to take my calculator. We're going to put those in. So 0.5 x to the third plus 2. And then we have x plus 1 for that one. So if I go to graph, there's the x to the third, and then here's the x plus 1. Okay, and we're told that we're only going from 0 to 2. So we're going from 0 to 2. That means the x to the third function will be the top function there. If I just kind of make a quick little sketch of that, maybe off to the side, I've got this graph that kind of looks like that, and then the line coming in like this. And we're going to sketch it from 0 to 2. So we're looking at that region right there. So it's going to be the integral from 0 to 2 of 1/2 x to the third plus 2 minus x plus 1 dx. All right, and we could do this by hand, easy enough. We could integrate that to x to the 4 over 4, so we could have x to the 4th over 8, 2 times the 4. We'd have a minus x, which would go to minus x squared over 2, and then we'd have 2 minus 1, which is 1, and that would integrate to x. So I'm simplifying this and then integrating in the moment. I'm going to do that from 0 to 2. So if I put 2 in, 2 to the 4th power, 2 times 2 times 2 times 2 is 16. 16 divided by 8 is 2. Minus 2 squared, that's 4 divided by 2 is 2. Plus 2. Minus, put the 0 in, you get 0 for everything. 2 minus 2 plus 2 gives us an area of 2. Okay? And again, I could kind of check that out real quick. Math 9, 0 to 2 of y1 minus y2 dx, and we get 2. So we're all set there. 21 wants us to find the area between these two curves here. So I'm going to take my calculator and clear that out. Let's go x squared plus 2x plus 1. And down here we'll go 3x plus 3. All right, hit graph. Here's the x squared graph, and then here comes the line. I need to find out where those intersect, and then I need to figure out what's top and bottom. So it looks like the line is top and the parabola, I can speak, is the bottom. So we're going to go 3x plus 3, the line, minus x squared plus 2x plus 1. All right, that will give us the area. We just have to know where to start and where to finish. Now, if you wanted to find these algebraically, you could set these equal to each other. Go x squared plus 2x plus 1 equals 3x plus 3. Subtract these over, you would get x squared minus x minus 2 equals 0. That's x minus 2x plus 1 equals 0. We get x equal to -1, 2. If I go back to the calculator, I could trace -1, and that sure does look like where they intersect. 2, that sure does look like where they intersect. Okay? I can use the intersect function as well, but that's, I think, confidence enough for me to know that -1 and 2 are limits there. All right? And then if we wanted to by hand, we could integrate this to -x³/3. We could do 3x minus 2x is x, integrate that up to x²/2. We could do 3 minus 1 is 2, integrate that to 2x, and then we could do our top and bottom. But I think with just, for ease here, let's go math 9, -1 to 2, and we're going to go y2, that was the line, that's the top function, minus y1, the bottom function. Okay, and we get 4.5 for that. So if you do that work by hand, you should end up with 4.5 for your answer. All right, for 26, we're trying to graph and figure out what's going on with that. So if I take the calculator here, let's go x minus 1 to the 1/3 power. That's the same thing as third root. And then we just have regular x minus 1 here. Okay, graph. So here's the cube root function, looks like that. Here comes the x minus 1. And we've got some stuff going on right in here, but it's kind of hard to see. So what I'm going to do is I'm going to do what's called a zoom box. I'm going to just box in this area. So I want to be kind of to the corner there, hit enter. I'm going to go above. I'm going to go this way. I just want to box this whole thing in. I want to see what's going on in this area. So once I feel like I've got it boxed in, I hit enter, and now it'll only show me what's inside the box instead of everything else, which is kind of nice. So here's our x cube root function, and you can see that we're hitting a value here at 0. That's our intersection. The line is above from 0 to what appears to be 1, and then it's below again from 1 to what appears to be 2. So if I was setting this up, I would set it up as the integral from 0 to 1 of the line g of x minus f of x plus from 1 to 2 the f function minus the g function. So that would be the setup based on what we're seeing here. So now if I take the calculator and go math 9, 0 to 1, we're going to go g minus f, so that's y2 minus y1, okay, plus math 9 from 1 to 2. Now we'll do it the other way. Okay, and it works that all out and gives us an answer of, wait for it, I'll get this one set up while we're waiting. Oh, 0.5. We'll trust it's a half. Okay. Now we could do this by hand. It isn't fun, but we could integrate this up to x minus 1 to the 4/3 over 4/3. This to x²/2 minus x, and we could do these things by hand. Like I said, they're not very fun, but we could do them if we needed to. All right, now this one we're doing in terms of y, and so when it says f of y equal y squared, what it means is your x value, the distance out from the y-axis, is going to be defined by whatever y value is squared. So when you're at 0, it's going to be 0. When you're at 1, you're going to be out 1. When you're at y equal 2, you're going to be out 4. When you're at -1, you'll be out 1. When you're at -2, you'll be out 4. So we end up with a parabola just turned on its side. That's all this means. Okay? And then the y plus 2 is the same thing. When y is 0, you're going to be out 2 spaces. When y is -1, you're going to be at -1. When y is -2, you'll be at 0. So it's kind of like this right here. Okay. When y is 2, you'll be at 4. So that'll be the same thing. They intersect at 2, 4, and at 1, -1. So in terms of y values, if we're looking at this shaded region right here, the furthest out is the line, the y plus 2. So g is the bigger function here, and the y squared is the kind of underneath function. So we're going to do g minus f for that. dy will be our little height for those rectangles. And we're going to integrate them from y starting at -1 to y finishing at, I'm sorry, I had these turned around. This is 4, 2. And y starting at 2. All right? So those are the points that they intersect. And again, we're just looking at the y values. We're integrating in terms of y. So we put it on the calculator. This is where it gets a little confusing, is because when I go to put it on the calculator, I have to use x for those values, right? Even though we're doing this in terms of y, when I plug it actually in here, it's x plus 2, which can get you a little confused, minus x squared dx. Okay, it gives us the same answer, 4.5. If we had done this by hand, we could see that pretty easily. But don't get too discouraged. When you set something up in terms of y or whatever variable, you're still going to be able to use that. You know, the calculator will still get you that right answer. All right, we come to 42, and they want us to figure out what's the area under this using a calculator. So I'm going to take our calculator here, and let's go x times the square root of 4 minus x divided by 4 plus x. All right, so that gives us that. I can clear this one out. Let's see if we can kind of get a visual on this here. I hit graph, and we're told to just use from here. Let me go out a little bit. Let's say we go out to 5. All right, so here it comes up. It starts here at 0, 0, and it finishes off at 4. So this is from 0 to 4, and we get a pretty good picture of it right there. So we are integrating from 0 to 4, this x times 4 minus x over 4 plus x dx. All right, so on the calculator, that's easy enough. I can go right here and go math 9, 0 to 4, y1 dx. Enter. And it's a little odd function, but we get 3.434 as our area there.